This is your first video for the acidic environment, and it's going to be on acidic and basic oxides. So first let's recap. An oxide is when an element bonds with oxygen and it'll form the element oxide. So there's a few examples we'll go through. So the first one, let's look at magnesium. So when we burn magnesium in the presence of oxygen, we're going to get magnesium oxide. And also another really common one, if we have iron, and if that's in the presence of oxygen, and of course it needs some water and air, we're going to create some rust. So we're going to create iron oxide. There are some other oxides that perhaps we hear about but haven't used that much in the lab. So the first one is sulfur in the presence of oxygen, and that's going to create sulfur dioxide. So we hear a lot about that with volcanoes. And another really common one, carbon in the presence of oxygen will create carbon dioxide. So all of these are oxides because they're an element bonded with oxygen. Now the thing here that we need to learn, magnesium and iron being metals, if metals bond with oxygen and form metallic oxides, they're going to be basic in terms of their pH. So we call these basic oxides. And when we have non-metals creating an oxide, they're going to be acidic. So we call these acidic oxides. So how do we know when we've created a basic or acidic oxide? We're going to start with the basic oxides, and we'll use the first example of our magnesium oxide. So we've got our magnesium, we want to find out what this oxide, its pH is. Now magnesium oxide is a solid, and luckily for us it's soluble in water, so it can be dissolved. So with this reaction what we can do is mix our magnesium oxide with water, and it's going to dissolve because it's soluble. Now remember back from our prelim course, when things dissolve they actually react with the water, so we're going to create ions. So we're going to create our magnesium ions, and they're going to float around by themselves. And we're also going to create two hydroxide ions. Now remembering from our last prac, hydroxide is what's going to create the basicness in the pH. So when we add our magnesium oxide with our water, stir it around, it all dissolves. We take the pH of that, and it's the hydroxide here that's going to give us the basic result. So it's going to give us a pH above 7. Now with our other example, iron oxide. Now iron oxide isn't soluble in water, so we have to do a different kind of experiment. What we can do, remembering again from our prelim course, an acid plus a base will give us a neutralization reaction. So we're going to create a salt and water, which should give us a pH of 7. So if iron oxide is in fact basic, adding an acid to it should give us a neutral product. So we can add the best acid we've got, hydrochloric, remembering that hydrochloric is an aqueous solution because it's already mixed in with water. And what we're going to do is create a salt, which is going to be our iron chloride. Oh, sorry, I should balance that. It's going to be our iron chloride, and we're also going to create water. So when we take the pH of this solution, we're going to see that it should be a pH of 7. That way we can confirm that our iron oxide was in fact basic in the first place. Now we can do the same reaction with our acidic oxides, or our non-metal oxides, to determine that they are in fact acidic. So if we start with sulfur dioxide. Now sulfur dioxide is a gas. We have it in our atmosphere. So when it's reacted with water, it's water in its gaseous state as well. So this is happening up in our atmosphere. And then obviously if it accumulates in a large amount will fall down as a liquid. So what we do when these two react, we create H2SO3. So please take note of the 3, it's not a 4. So this is in fact sulfurous acid. Sulfurous acid. Now if we had SO3 gas, now this one is more so common in our atmosphere. It's sodium trichloride. It's actually responsible for acid rain. So when this occurs in our atmosphere, we're actually getting H2SO4, which is what you're familiar with, and that's sulfuric acid. Now, exactly the same thing will happen with carbon dioxide. Again, it's a gas. So when it's in the atmosphere reacting with gaseous water, it's going to create carbonic acid. So H2CO3, and this is carbonic acid. So to sum up, you've identified oxides of metals and non-metals, and you've described the conditions under which they act as bases and acids. So that's the reaction with the water. So take notes, and I'll see you in class.